Hello, anti-architect and building conversation podcast listeners. I am your host, Christian Giordano from the Anti-Architect podcast and Mancini Duffy.
And I am your co-host, Jason Vesuvio from Building Conversations podcast and Pavarini McGovern, which is an STO building group company. Today we have a special joint episode of our two podcasts. We're going to dig in deep into one of the most fascinating construction projects maybe ever.
Yeah, I agree. So I'll give you a quick overview. Excuse me. I'll give you a quick overview of TSX Broadway. It's located 1568 Broadway and 49th Street in the heart of Times Square. And at this point, as of today's date, I don't know, this is like November of 2020, it is about 80% complete. It's located on the busiest corner of the most heavily trafficked public space in the world. When complete, it will be a one-of-a-kind entertainment venue, hotel, retail experience, and, of course, it has this landmark Palace Theater. It's 48 stories tall, 581 feet to the top of the crown from the sidewalk. 16 of those floors are old, what we call retainage slabs from the previous DoubleTree Hotel. We'll get into a little bit of that and how that works. 585,000 square feet in terms of square footage, with about 100,000 square feet of retail. It'll have one of the most unique LED facades in the world, with the world's largest digital doors and a performance stage behind them. 661 hotel keys, 18 of which will be what we call the ball drop suites. So they have a really cool view of Times Square and when the ball drops. There's galleries, there's entertainment, there's restaurants, and of course the historic Palace Theater with about 1,671 seats. And the Palace Theater opened in 1913, and this past May of 2022, it was raised 30 feet, which is what we're going to be talking about today.
So that's it?
That's it. Just a small project.
That. Yep. Yeah. So, look, any project you can say the same thing about is nothing without its team. And certainly, while that ends up with people, I think it starts with firms. So I'm probably going to forget some people. So I feel like I've just maybe won best actor at the Oscars, and my list is unfortunately going to be truncated. But we'll provide links on both of our websites just in case. So we have L&L Holding Company, Fortress, and Mayfield, as well as Niederlander Organization up at the top. I'm with Pavarini McGovern, like I said before, the construction manager, part of the STO building group. Our sister company, Structure Tone, here in New York, is also part of our team. Mancini Duffy Architects as the architect of record. Perkins Eastman on the facade. Platt Beyer DeVell White on the theater interiors. Urban Foundation and Engineering. Severud Structural Engineering. Cosentini on the MEP. We have Langen, VSL on the wall. McLaren Engineering. Wimberley Interiors. Goes on and on and on.
Yeah, I'm sure we missed stuff, but we'll put it on the website to make sure that we don't get anybody angry.
For sure.
All right, so just some quick introductions of our panel. Tony Mazzo. Tony Mazzo is the president of Urban Foundations Engineering, LLC, and has been involved in several notable projects, a few of which include the Statue of Liberty restoration, Citi Field with the New York Mets, and the restoration of 6 landmark theaters in Times Square. Tony is also the inventor and owns the patent for high-capacity cylindrical core beam for drilled-in caissons. Sorry, that's a lot. Which is what was used to support the building that we're going to be talking about today. He is a member of a number of professional organizations and holds a bachelor's and master's degree in civil engineering from CCNY.
Sounds like Tony's uniquely qualified to be on this team.
I would agree.
We also have Joe Levi with Pavarini McGovern, project manager, specifically on the core and shell for TSX Broadway, with over 20 years of experience on some complex projects. Expertise includes life sciences, retail, hospitality, residential, higher ed. Joe has a BS in environmental science from the University of Rochester. Hey, Joe.
And we have Bill Mandara. Bill is the Chief Executive Officer at Mancini Duffy, where he spends much of his time leading the firm's efforts in new buildings out of the ground, adaptive reuse of existing buildings. Bill has been involved in several projects, including Brooklyn Army Terminal, 575 Lex, Peloton, several projects with more like thousands of projects here at Mancini Duffy. Bill resides in Paramus, New Jersey. It's very important that we mention that. He holds a degree from New York Institute of Technology. He is an amazing drummer and has several albums out on Spotify right now.
Yeah, I was going to say, wasn't there just a brand new album out right now?
Just released an album, yeah.
Unbelievable. I can't believe we got him. We also have Benji, who's an associate principal at Severud, a structural engineering firm, very well known, obviously, here in New York and elsewhere. Been with the firm since 2005. You began your career there. You're a licensed structural engineer in California and Nevada, as well as 6 other states. And you have a bachelor's and a master's in civil engineering from Cooper Union. And I understand that you made this building stand up while we made Swiss cheese of it during construction. Is that true?
That's our specialty.
Okay. That was just handed to me. I didn't write that. I can't take credit.
Can we back up a little bit, and can you guys just all kind of talk about your individual roles on the project?
Sure. I think I got us a little too far.
My name is Joe Levi. I'm a core and shell project manager for Pavarini McGovern. I've been working on TSX Broadway for the past 5 years now. I was involved in pre-construction, working together with Tony and Ben in Severud and, many other places in conference rooms and structured tone organization, trying to coordinate the combination of the theater lift, the temporary bracing. I was responsible for procuring some of the larger contracts, the foundation excavation contract, superstructure concrete, and a number of others. And over the course of the past 5 years, I've been hand in hand with these guys and also with a lot of your cohorts over at Mancini Duffy. I sit across the table from John McCampbell and Anthony and Keith Lesser and Jenna. So we've all been working together as a team, and I've been, lucky enough to be on this project, and it's honestly been really a game changer in terms of just my understanding of how to approach probably what will be one of the most intense, if not the most intense, repositioning projects in New York City.
Mm-hmm. Awesome. Thanks, Joe. Ben?
I'm Ben Alper. I'm an associate with Severud Associates. We are the structural engineer of record for the overall project. So we're kind of overseeing sort of everything that's done. Again, there's you listed a whole bunch of engineering firms that worked on the project, but there's got to be at least a dozen different structural engineers, including Tony, in different aspects of it, whether it's the foundations, the SOE, the sign, all different parts. So we worked together with everyone and really made sure that we kind of all worked together and we're all on the same page. And that was certainly a difficult effort. And Cassie Gigina, who's the engineer of record from our office, the principal in charge, he really had a good vision for this project early on. And I think we started this, 7, 8 years ago, Tony, something like that. Yes. So we've been working on it for quite some time, and it's just great to see it to come through. And just to echo what Joe said, it's really been a pleasure working with everyone. We've been doing this together all for quite some time, and it's sort of great to see it go by and walk by and see it done. So just a pretty exciting project.
Awesome.
I'm Tony Mazzo. I'm the president of Urban Foundation Engineering. I am the foundation contractor and the design build lift contractor for this great TSX project.
Awesome. Bill?
And Bill Mandara. So, we are Mancini. Obviously, we're the executive architect, and I'm the architect of record, the guy whose license goes on all these things. So there's a great deal of trust between all the individuals here. And my job really is to make sure that our incredible team that Joe mentioned before, with John, Tony, Keith, Jenna, a lot of people that Anna, a lot of people that haven't, Rebecca, a lot of people that have came and went as well, have all the resources and everything they need to do the work, because they're really, they're over there with you guys doing the Lord's work over there. And so that's kind of my job. And Christian, you'll remember when this project first came to us, we both had our doubts about how real it was. And as it became more and more real, and when L&L became involved, we were like, oh my gosh, we got to really do this, and we really have to put together a team to do it. And I remember my dad was a contractor many years ago, and I was sitting down having dinner with him talking about this. I'm like, this is this crazy project, and I looked at the thing, and my father's like, look, take it seriously because this could be a really big project at the time. I'm like, nah, it's never going to happen. And here we are. So like everybody said, it's an honor to be part of the project.
Awesome. So we want to get into talk about the project as a whole. But I think what we'd love to dive into right away is hear from all of you on the specifics of, we made reference to it in the introduction. We took this old historic palace theater that's existed for, what did we say here? 50 years plus. And we elevated it up 30 feet in the air. We want to really get into detail about this. A, why did we do this? And B, how the heck did we do this? So we'll kind of throw it out to the panel here to let's get right into it.
I mean, the obvious why we did it was to create this incredible space on Times Square that didn't exist before. Literally the most heavily trafficked intersection in the world, I think, is what the statistics say. By raising that theater, you're creating space that did not exist there. So that's the why. Now, how is a lot more complicated, but obviously there's a huge team of people. It's represented in small part by some of us, but a lot of trust, that's for sure, given everybody had to rely on each other here.
So Eric McGovern calls me up one day. I'm in my office in the afternoon, and he says, I got to ask you a question. I said, sure, ask away. He says, I got to lift a theater in Times Square. Are you interested? I said, absolutely. He said, you need any help? No, I don't need anybody help. He says, Tony, that's you, Tony. I know that's the way you are. Okay, let's do this. And so we embarked on a project that I think most engineers would appreciate is a once-in-a-lifetime opportunity.
For sure.
To do something that has never been done before, I don't think, in this country, to the magnitude that it's been done, the scale, and the location, right in the heart of Times Square. Times Square is not strange to myself. As you mentioned, I've been involved in the renaissance of Times Square in the 90s, where we refurbished maybe half a dozen landmark theaters. And then in 1998, we actually moved the Empire Theater on 42nd Street 170 feet west to its new location, and now it is the lobby for the new AMC Multiplex Theater, which is why I was qualified to at least have a conversation about lifting the Palace Theater. It was once in a lifetime. I thought that when I was introduced to this and I went through this is going to be my legacy. Nothing is going to top this. Even though I've done some iconic structures, like I'm a Queens boy, so I was born in Queens, so I'm a Mets fan, so I did the new City Field. I did the restoration of Statue of Liberty. I thought that was the cat's meow. And I've done some very cool things. We did Times Square, we did not only Times Square Tower and other Whitney Museum. We did some very iconic structures, but never was the task to lift the theater in addition to doing the new foundation for this remarkable tower.
Which is one of the things I think that is most interesting about this project. I mean, Christian kind of covered it a couple of minutes ago, but this is like 6 projects in one. There's so much going on at one time, that dance, especially when you think about, some of the major contractors that were all on site at the same time. Construction is rarely linear in a sense, but typically you'll have, excavation and foundation be replaced by superstructure, and then you begin that dance up. Here you had, the underground, the structure, the excavation happening at the same time while we were doing major structural demo. I mean, planning for that type of project with all of its parts is just absolutely, I would think, unheard of. What are those conversations like?
Well, contractor first.
I want to give Tony the credit. What you guys didn't mention is that literally we lowered the cellar. We added an additional cellar while Tony was there jacking that theater up, or actually right before. He actually excavated out a full cellar below the theater. Yeah. So like you said, when it's things in parallel, people, you talk about a theater lift because that's, something very, very unique, but lowering it by a full cellar while you're trying to do, do both things at once, it's a whole nother level. So go ahead, Tony.
Well, we had no choice.
About it.
It took about it. We had to wait about a year and a half before the structure above the existing theater would be ready to receive the 30-foot lift and tuck it into this carved out pocket.
And talk about that a little bit too. That's the very interesting thing.
Well, the existing structure, and I think Ben can speak better, but I'll put it in simple terms, and Ben will expand on it. There was a truss that straddled the theater 100 feet up at the top of the theater. The new truss had to be installed 30 feet above the existing truss so that 30 feet that's immediately above the theater could be carved out, and we could tuck the theater right up into that new slot.
Creating basically a cavity, right?
That's correct.
Right, because the original theater was there, and then the hotel was built over it.
See, that's a really interesting thing, right?
Right. Yeah. They I mean, and we took, they had, I'll call it a bridge. They originally built a bridge over the original theater when they built the hotel tower above. And we had, like Tony said, he had to slide that theater up into the pocket, but the pocket had to be created. And what we did is, like Tony said, we created these one of a kind post-tension beams that we cast on site that are amongst the largest in North America. And we tensioned them in phases as we built the structure. And those in themselves are unique, again, but we always get lost on the theater lift because that,
yes.
There were so many moving parts and pieces, and I think what made it even more complicated, obviously you had the theater lift element, but then you also had all these things happening in and around the theater lift. The demolition of the tower above, excavation, at the same time as structural stabilization of the existing tower. Some people don't even know this, but there was over 168 tons of temporary steel bracing that was installed in the cellar. And many of the first conversations that I had when I was in a room with you and Benny over at Severud Associates was how you're going to fit your rigs in and around this temporary bracing. So Tony had, thinking out of the box as he does, came up with an idea of obviously modifying your rigs to work around all these logistics.
We did. The task was to drill conventional 36-inch diameter caissons, which are really 36-inch diameter shell holes, 60 feet down below, underneath the existing theater and hotel, in maybe 16 foot of headroom. And while we had some opportunities to drill those holes with conventional equipment, there were many areas where we didn't have 16 feet. And so my genius chief engineer, Rick DeLuey, came up with a design for these caisson rigs that can drill 36 and or 42-inch diameter holes 60 feet deep within 12 feet of headroom. And we called them the Red Dragons, right? We tried one, and it was so successful, the owner said, you got to make a second one right away. You got to make a second one right away. And we did. And for reasons that became a benefit to the theater lift project, it was a good thing that we did. And the reason for that is through a period of design, redesign, and so forth, for reasons that were evolving as the job was evolving. Remember, Joe said there were maybe half a dozen trades working at the same time. So their work was also evolving and being put in place at the same time. So much so that my original design to lift the theater had to be put on the shelf because there was physically no room, either outside the theater or within the theater, to actually install the lifting system that I had originally designed.
And I think that's actually important. When I walked into the original conversation, Tony had this original theater lift design in which you were lifting slabs. And I think, if you were to explain that to people.
So when you do something for the first time, your mind goes in 100 different directions because there's so many options. There's no script. There's no history. We're going to create history. That's exactly what we did. And so in doing so, I had to make sure, all right, everybody's going to watch us do this. So you better not screw this up. You better overthink this thing to make sure you've turned over every stone and looked around every corner to make sure this thing is going to be absolutely perfect and without scrutiny, without criticism, and say, you know what, This is the standard of how you're going to lift the building. Meanwhile, I haven't done it yet. So you tend to, as engineers, we tend to embrace convention and conventional designs. And that's exactly what we started with. A conventional design that had lifting frames that could straddle the theater walls, and then a jacking mechanism that could push the theater up. Unfortunately, they told me there's no room for any of that, Tony. So we started back from scratch, and I said, okay, look, we need three things. And with the help of Ben, he made it very easy for us. I said, look, we're going to need a rigid diaphragm at the base of the theater box that we're going to lift, so that we know the theater will always stay square, and that it will be very forgiving when all the jacking points are simultaneously moved, and there might be a little bit of differential movement between one and the other. So we built a ring beam, and we employed the new third floor steel, which is very heavy steel, which is the new theater auditorium seating, and that became the rigid frame. The second thing we needed was a jacking mechanism. And they just already told me, Tony, you can't do it the way you said you're going to do it. So, okay, we went back to the blackboard.
Can you talk just very quickly why?
Well, because I needed room on either side of the perimeter wall. I needed room on the inside. Mm-hmm. But unfortunately, the electrical people were putting in these big major duct banks that they needed to provide power to the tower. Mm-hmm. And on the outside, we were wrapped with scaffolding, so all the sidewalks are occupied. So I had no room on the outside either.
The tightest of tight sites.
The tightest of tight sites. And I was trying to have a say in this, but how can I have a say when everyone signed up for this job to do this job simultaneously? We were said, this is not going to be easy. That's why you're here. Okay, well, if that's the rules of engagement, I'll take it from there. And there was only one time during this whole redesign process that I had an epiphany. And I said, wait a minute, I got it. Because the only room we really had was literally underneath the theater wall itself, because we would extend those walls later on. So there was no other permanent structure going in there. But it happened to be for that year and a half that we were waiting for that cavity to be created, we also had the foundation contract to install 55 36-inch diameter caissons, 60 feet down, most of them predominantly in the tower area, but a few distributed around the theater east side, so that, again, they're going to create a new bridge over the new theater that's raised 30 feet in the air, and these 36-inch diameter caissons were going to be the new supports. And it was only when I was looking at it, I said to myself, you know what we need? We need a telescopic system to raise this theater. And I said, the easiest thing, if they could sell it, is a 30-foot diameter, 30-foot stroke hydraulic jack. Imagine if they sold in Home Depot a hydraulic jack that can extend 30 feet in the air and jack up to 600 tons.
They're going to need a bigger store.
Well, obviously that was unheard of, but the concept was a very powerful concept. Why? Because if you look at the configuration of a 36-inch diameter caisson, it's a steel casing, 36 inches in diameter, and there's a beam inside of it that goes all the way down to the bottom of that
You got
caisson.
the room.
So I'm saying to myself, well, this is a perfect telescopic component if I could figure out a way to let that beam on the inside of the casing extend 30 feet up in the air, out from the original casing that it's sitting in.
Tony, how do you get to telescopic? I mean, is it in the middle of the night while you're tossing and turning, you're making coffee on Sunday morning? What's that epiphany?
He makes it sound like he's changing the oil on the car.
It really is amazing. It really is amazing.
Buys it at Home Depot.
How does that come to you, that epiphany?
Well, the truth is, back in the early 90s, the Coca-Cola Bottling Company of New York had a massive storage plant for which it had 80,000 square foot of storage with 14 foot of headroom. These were the post-World War II warehouses where they made warheads during the World War II, and every warehouse in Queens was 14 feet high. And they said, look, if we can raise this roof 80,000 square foot, another 8 feet, we can increase our storage by 50%. Tony, without ripping out 80,000 square foot and rebuilding, what do you think? And I looked at it, and it was a simple steel frame building with open web joist. That's a little technical, but Ben knows what I'm talking about. I said, what if we were to make those columns stay where they are, we'll reuse them, but we'll make them telescopic? And he looked at me, he says, telescopic? I said, yeah, we're going to let the column stretch another 8 feet. And the concept was very simple. All we needed to do was sandwich each column with 2 other columns, and then put a beam on the top of the outside columns, drape down some threaded rods to catch the bottom of the original column, and just jack it up from the top and pull it up by its bootstraps.
And then what do? Fill it back in?
No. Those the 2 columns that straddled the original column, you weld them together, support. And there's your new column.
Interesting.
Engineering sounds so easy.
It's so easy. So, Tony, I want to go back to the theater itself, right? And we can talk a little bit about the other aspects of the building. But there's obviously a lot of prep work that goes into the theater. It has to be preserved. From what I remember, the seats came out. It was essentially stabilized at that point. You guys dig under, you create this sub-foundation, you come up with the idea of the telescoping caissons. How do you physically detach the theater itself from the ground, right? Or wherever the heck it's sitting, without completely screwing up, 100-year-old plaster inside? And then do you monitor it? How quick does it get lifted? Is it lifted in 10 minutes or is it lifted in 10 months? How does all that work?
Well, you do it very carefully. And you do it with industry standards that take high, careful care in surgically cutting the existing foundation away from its original foundation that you're going to abandon. And so we work with small equipment. We work with very skillful guys that we have, and they were remarkable. We had to construct, as I said, we carved a ring beam underneath the theater box that's going to be lifted. In order to do that, we had to shore the existing theater, so whatever we're going to do below it, whether we're going to surgically remove a piece of the wall to infuse this ring beam, or we're going to excavate down 30 feet from street level, which was another 18 feet from the existing cell level, and take out 7,000 yards of earth and rock, small way, and conveying it through the theater basement and up through the back house of the theater itself, the stage area, and walk it right out 47th Street. This was all orchestrated with great planning and scheduling and coordination. We spoke about there was about 4 major subcontractors working at the same time, and my concern was they're not going to give any street frontage to work from because they need it. So we created a new street called the stage area of the Palace Theater we created a trestle coming in from 47th Street right across the theater stage, and it enabled heavy trucks to come in, be loaded from inside, and pulled right out. So
a lot of concrete you poured for that, right? I mean, in and of itself,
thousands of yards. Yes.
That was an impressive. You're calling it a trestle, but it was basically you poured a new slab, temporary slab.
Well, and a big steel truss.
Yeah.
On caissons in order to. That was the main artery to the job. It was the key to the job. There was no other way to pull trucks in from the front when 3 other contractors needed that frontage to pull their trucks in at the same time. So we drilled these caissons to initially hold the theater up so that no matter what we did below it, that theater would stay exactly where it is. And so the first thing we did was install these 36-inch diameter caissons all around the theater and some of the interior columns at the proscenium arch, at the balcony columns, all of which we properly did load transfer. I want to remind you, Urban's been doing this kind of shoring work in New York. I'm with Urban 42 years, and I've been doing it ever since I got there. So this project in and of itself is the culmination of many years of doing different facets of those mechanics that are required to both hold the theater up and eventually to mobilize it to its new location.
You know,
go ahead.
Sorry. I think one of the most fascinating parts of when you were stabilizing the theater was when you hung the orchestra slab. And when you originally started talking about that, you know, maybe 5 years ago, I couldn't visualize it. But then all these mini caissons started going in within the perimeter of the theater, and you started building this enormous truss. These massive steel beams were basically rolled on top of the existing orchestra slab. Pockets were cut through the orchestra slab, and within a period of almost 3 months, the entire orchestra slab was suspended on mini caissons below.
So the existing columns that held up the orchestra slab could be removed because they were too short, right? Because we were going down 30 feet.
Right.
So that was the first thing we had to do, is hold up the existing orchestra level, the first floor level slab, the seating area. Hold it up from above that area, the surface of that floor, so that nothing that was going to hang there for a few years was going to be in the way of the new construction down below.
So it hung there for a few years while you basically excavated underneath it.
That's correct. That's correct.
It's insane.
But it was just very spacious. It wasn't very heavy, but it's spacious. So there's a whole lattice of steel beams and hangers and mini caissons in a grid to hold this floor up. Okay, that was independent of the system we needed to hold the theater up. The theater, which as you can imagine, is much heavier, 14 million pounds heavier. So there we needed larger caissons, which were the 36-inch diameter caissons.
And that's an interesting point too. Like, let's throw out a few numbers. So it's so we lifted the theater ultimately about 30 feet in the air, so roughly 10 meters, maybe a little bit less. The theater itself is 14 million pounds, 113 years old. Let's talk a little bit about the mechanisms themselves and what I would call the control room that I remember seeing underneath the theater as it was going up. So 34 lifting posts, 136 jacks.
Yes.
So, roughly 4 per.
4 per.
And people. It wasn't just the technology and the machinery, but it was people as well. Talk about that process.
So we integrated old world techniques with new world technology. We always did out jacking work with a company called WB Equipment out of Jersey. And my friend Steve Sirico came through for us when he found this manifold that can control up to 48 jacking systems at the same time. So we had 34 that we utilized, but we had redundancy, which we needed in case some of those ports, for some reason, had a failure. We were able to reconnect to another port and be able to operate the lift. This manifold controlled 34 lifting stations, and it could control the speed of which the jack was extending. It'll measure and monitor and maintain whatever differential elevation there is between them during any cycle of lift. And it could actually control the load, the maximum load that would be on one particular lifting mechanism. It would hold it to its max and then send the load to the one adjacent to it until its one caught up. So it was very, very sophisticated. Notwithstanding all that new world technology, I'm an old-fashioned guy and came from an old-fashioned way of doing things. So we manned in 34 locations. We had 2 dock builders standing right there, making sure that the jack's extended, making sure that the plates, that the steel that was pulling up on the bottom of the core beam inside the caissons wasn't inhibited in any way, operating the threaded rods that obviously had to be turned down every time we lifted. We had to turn nuts down, and it was as simple as it was
by
hand. But yes, that because we oiled everything. The system we came up with is so simple. All the dock builders had to do was sit and wait and turn X nuts. That's all they had to do. Right. For a sequence of 5-inch lifts. We lifted in 5-inch increments, for which then we had to retract the jacks, run the hex nuts down, start again. And it took 25 minutes for the theater to extend all the jacking systems to extend 5 inches. It took about 35 minutes for the entire system to retract and reset up for the next cycle. So in an 8-hour shift with some, okay, let's stop, let's look, let's measure, let's make sure the monitoring has done its job and that everything is working and everything is according to what we planned. We were able to average about 2.5 feet per 8-hour shift.
Wow.
And so this whole 30-foot lift was done in 2 phases. We lifted approximately 18 feet in the first phase. And then a few weeks later, we lifted the other approximately 12 feet.
Which is remarkable because originally we were talking about a 2-month period for the entire duration.
Yeah.
So you contracted that period into, what was it? Really, it would have been only
2.5 weeks,
2.5
maybe.
weeks.
Yeah. Yeah.
Insane.
I've heard this story so many times and it never ceases to amaze me.
Not in that level of detail.
No.
In this next segment, the group discusses how the structure reacted to the initial lift. Worker safety was a top concern for the entire team throughout the project, and all falling brick and debris was safely contained.
So I feel like we skipped over a few things, and Tony does that obviously because he in his world, this is all easy as turning a few nuts. But going back, there was a point in time where the entire theater was suspended. All the excavation had been completed. So you can imagine this entire theater sitting on lifting posts and small interior caissons, exterior larger 36-inch diameter caissons with your posts within them. And the cellar was down approximately, what was it, almost 25 feet?
Almost, 28 feet, I believe.
28 feet.
Yeah.
So you would actually be able to go in below the theater and look up and see almost the entire space, the cavity below the theater. And it was, anybody who'd walk into the cellar at that point knew how remarkable it was to see a theater just suspended in air.
When we started, you couldn't see daylight because the theater walls that remained were down to approximately the existing cellar level. By the time we finished, you could see 18 foot of daylight below those same walls that started 13 feet below.
Unbelievable. Let's go back to that, maybe that very first night. I was talking to Eric McGovern, Pavarini McGovern CEO, about this. And he recalls the two of you, and there may have been more people, but he recalls the two of you, Tony, testing the system the night before. He called it the night before the Hollywood lift. you did, and wanted to, shake or be sure that the foundation was cut, removed. And I just said, what was that like? He said, he described the sounds. He said there were these amazing pings and things were shaking and you could hear concrete and steel rubbing against one another. But his line was, it was like we were in the belly of a whale. What do you remember about that night? And the same goes for the three of you when you were first seeing the lift. Go ahead, Tony.
It was a really interesting experience. We anticipated the pings that you were talking about are the movements of the steel girders and their connections, the stressing of the threaded rods that were hanging the lifting posts, the crunching of masonry as it rolled past its joint. The crumbling bricks were coming loose and falling. The theater was talking to us. It was saying, it's okay. We're going to do this. It's fine. Everything that awesome. I'm talking to, everything that you hear is what you anticipated hearing, and it was absolutely magical.
Wow. Let's talk a little bit about the building itself, right? And the fact that it's a new building, but not really. It's also a renovation because we kept portions of the building. I remember an early on conversation, Benji, you were telling us, you guys got to remember that you've got to keep X amount of the slab left. We're poking holes through this. You have to keep it. And I remember leaving that initial meeting so stressed out, like, how are we going to do this? There's no way. I mean, we're talking about keeping tiny little 1-inch pieces or every little half-inch counts. Why did we need to keep the slab? And then how did we go about, kind of making, as we made light of it, Swiss cheese of it, but we really did at the end of the day.
Bill, why don't you address why we needed to keep the slab?
Well, yeah,
and then I'll address the easier
fair
part.
enough. Well, yeah, Christian, you got nervous. I was looking up countries with no extradition treaties to the United States at that point in time. Yeah, the reason we did that was because the project is not a new building; it's an alteration type 1. And in order for us to remain in alteration type 1, we had to keep 25% of the floor area. And why that's important is because the existing structure was overbuilt. I don't recall the exact number of how much, but it was a significant amount, whereas if we did not retain that floor area, we would have had to build a much smaller building, which would have made the project financially infeasible. We had a lot of, and I think this is why Benji punted this one to me, right? Facilities. We had a lot of meetings on what does floor area mean? There's some people that took it as a literal, it's people who throw around the name retained slab, which is actually a misnomer because nowhere in the zoning code anywhere does it say anything about its slab. It says floor area, but there was a lot of different opinions on that and what that means, whether it's, area that existed before. So if the area that existed before had a big opening, well, that's what the area was and you're keeping it. Because again, I couldn't find any countries where I wanted to live that spoke English and had no extradition treaties. Mm-hmm. We went with the most conservative approach on that, which was to keep more so of it than we need. We had a good bank of it available, several thousand square feet beyond what we needed to be over the 25%. And it's a good thing because this is where Ben comes in. There was times where there was areas. I mean, there's a lot of work that was done between John McCampbell from our office, the demolition contractors, and multiple engineers, including Severud, everybody, where we'd say, okay, we're keeping this chunk of slab here. Okay, great. And they're like, yeah, but we need to poke holes in there to get temporary structures in there or to get lifts through or things like that. So, okay, that doesn't work. And then we would go back and we'd get it all perfectly done. And then we'd go over there, demo something and be like, oh, well, this slab is a hunk of garbage and falling apart. So we'd be like, rats, have some in the bank. So we ended with, thankfully ended with some square footage in the bank, which makes me feel better.
Yeah, I'd say part of the challenge also is that we weren't just trying to retain the slab, but in many times we were reusing it for different usage that had a higher live load demand. So, we were taking a hotel floor and trying to use it as a restaurant. So we couldn't just try to retain it in place. We actually had to retain it and strengthen it. So we had a lot of different ways of doing that. A lot of times with taking a set, let's say an 8-inch slab, and pinning an additional 4 inches on top of it to strengthen it to make it effectively a 12-inch slab, and a lot of different techniques. But another thing that Bill said, as we had these means and methods issues, and we were trying to sort of erect the steel in the middle of the existing floor slabs. So it wasn't just like, you had an open space and you'd bring the steel in. I mean, we were fighting over, literally, we'd fight over every hole. Every hole they'd put in to bring a steel column and brace up. We would fight about how big it was. We'd sat there with all the engineers in the room and PMG, kind of the arbitrator, and we're just like, no, that's too big. Cut down an inch or two.
Just as there were 170 tons of steel just for temp bracing in the cellar, there was another 170 plus tons of steel in the West Tower for temp bracing as we were making these holes. So, it obviously presented a challenge, not just in the construction, but in the demolition sequence as well. So as all these slabs were being, sliver removed here, a small sliver here, we had to install bracing and then figure out a way to rebuild a new slab or beam or truss around these temporary braces.
Yeah, I mean, I'd say one thing about this job is that people all the way through, and Tony touched on this, all the way through as the job changed, and the job was changing on us, I'd say day by day. Mm-hmm. And you had Pavarini and you had Tony and all the subs, no matter what got thrown at them, they didn't just say, okay, I had this idea and I'm going to stick with it, I'm going to make it. They reimagined the idea, mm-hmm. and they took it and they sort of started new and said, okay, let's do what's the best. I don't care that I had this idea. Let's start from the beginning and sort of and every day, almost every day, it seemed like we had a new challenge and people would reimagine it from the beginning and sort of.
We were working hand in hand with Shapiro Associates, also with Severud, constantly on a day-by-day basis, trying to determine the extent of interferences, and work around them and try and find a solution. Megan Krupka, your field engineer, she did a fantastic job of working together with us, and I think that was the only way it was accomplished.
She did an amazing job. I mean, it was
to be able to find and solve and almost immediately find solutions so that we could keep going. You know, when you have 125 guys from Sabara on site, there's no way you're going to stop for a day. You just got to keep going.
Speaking of reimagining things, the third component of successfully lifting the theater is making sure it doesn't fall out into Times Square.
Yes, that makes sense.
So,
that was my next question. So now how do you finish it?
Okay, so as I told you earlier, there was no real estate on the outside because we were wrapped in scaffolds to build what I had originally conceived as temporary frames that had vertical rails on it that I can attach to the theater, and the theater would virtually be guided by these exterior frames.
But you had what? 4, 5, 6 inches in between, right?
There was no room at all because the scaffolds occupied all the outside space. So once again, in the middle of the night, I had an epiphany. And I realized, as if you can envision, that the original tower that straddled the theater had sheer walls surrounding it in 3 corners. And so I said to myself, there's the frame. All I need to do is design a guide rail to attach to a vertical guide rail that goes 30 feet up these sheer walls and connect it to that base, that ring beam, rigid diaphragm. So we literally grabbed the theater by its waist and kind of lifted it straight up.
Like Dirty Dancing style or something?
Kind of like
the Notebooks?
Yes.
More like Simba.
You say Circle of Life.
Yes.
Amazing. So one of the things that, and the project is still going on. The restoration of the theater is happening right now.
I think we're basically done. So.
Yeah. You guys did the hard part. But and maybe this is more for Bill or Joe, but talk about the inside of the theater and the prep there. I mean, this is for those listeners that are outside of New York City, this theater is a New York City landmark, and there are some stringent requirements around that. Talk about how you, not so much the restoration itself, which is, beginning or ongoing now, but the prep work, sort of the interior skeleton and what you needed to do.
So prior to the theater lift, obviously, there was a whole bunch of other consultants that were engaged, which presented a few more challenges to the team. I think we worked around them quite well. As a matter of fact, I think Tony is probably responsible for, getting us across that hurdle. There were a number of things going on at any one time, including vibration monitoring, temporary stabilization of the exterior facade, stabilization of the interior plaster. So they went around and did an entire assessment and took photographs of the entire theater. And a consultant also went around to determine what was stable, what was not. If it wasn't stable, they tried to stabilize it using scaffolding systems. The entire proscenium archway was, for the most part, stabilized, and there was a temporary partition that was placed on it because, as Tony told you before, Tony's main means of access was the theater stage. So there was this major gap, obviously the stage area, which would allow moisture and humidity to come into the theater. So we had constant temperature, humidity controls running from day one. As soon as we cut the power, we had temp power going into the theater, running humidifiers, dehumidifiers, heaters, coolers, you name it, with someone there 24/7, even up till this day. So this was obviously a massive undertaking. I mean, there's just nothing small to it. Everything around the theater was stabilized. Tony, you could probably speak a little bit more to any of the foundational elements.
There's a subway going past there too.
That's true.
It was, and but that wasn't as much of a concern, except for when we were doing foundation work around the subway area. The neighbors were obviously very concerned as to, how this would work. I think Tony could speak to that a little bit.
But the pigeons on the roof didn't know the theater was moving.
That was a normal day for them.
That's great. That was the mission of it.
Yeah.
I mean, you guys spent how long just stabilizing the interior of that? And again, the amount of agencies, not not the least of which was the actual owner of the theater. We had a lot of concerns about that. So
we were stabilizing up till the day of the lift, and even after. So once Tony did his test lift, we found some areas where there were some walls which were actually not landmarked walls, which need to be removed, and we were concerned that they were going to fall during the lift. So we went through that night and took out some small partitions. So everything was happening live, and at the moment, it was a nonstop performance from day one when Tony came up with this concept, up to about the end of the theater lift.
So that's an important point, Joe. It's not that the entire interiors of the theater were landmarked. There were certain sections.
That's right. So there were certain parts, and we had to pay close attention to them. So the original entrance into the Palace Theater, which extended from 7th Avenue through the West Tower of the old Doubletree Hotel into the theater, that wasn't actually a landmark space. So that in and of itself was able to be removed. So now the lobby, when you walk into the theater, is going to extend from or start from 47th Street, and you're going to take an escalator up to the third floor.
Right. So, that's one of the things, too, is that because we still call it the theater box, the actual landmark stuff and actual pieces that were in there. There was a whole other set of challenges with how that interacts with the new building. To your point, Joe, the new lobby that we created on the third floor, all the front of house, all the back of house items, because even though we have this historic theater, we're subject to all the current rules and regulations for restrooms and life safety and all those things. So having that interact with the new modern building was quite a bit of a challenge as well. Not to mention, not that you could do a whole other podcast on the acoustic concerns with this project.
I was just going to say, so there's a acoustic separation between the theater and what is going to be the future stage that projects out to Times Square on the third floor. So there's obviously constraints that you're aware of, that are pretty high when it comes to, the performance happening at the same time on the stage on Broadway, and a performance possibly happening at the same time within the box of the theater.
And it could be big performances. You could have a full-scale Broadway musical going on in that theater, and you could have potentially U2 out there playing. Who knows? I'm dating myself with the reference.
And a lot of advertising happening on the LED around the podium and up the building.
And at the same time, you could have a retail tenant or some experiential tenant blasting music or God knows what as well. So, and all those things have to happen, outside of each other and without hearing each other.
As a New Yorker, I'm glad it's happening in Times Square, not my neighborhood.
And I'll say this too. We spent months on just stairs alone in this project.
On stairs alone.
Stairs alone. I know that's because one of our guys, Keith, he was on stair duty for months and months and months, and it seems kind of silly. And I don't think I really understood why until he explained it. Look, you were basically creating a new state-of-the-art, brand new tower that had all updated egress challenges that had to go down, around, through, and not into, past, an existing historic theater. So how do you get from that top floor all the way down through that theater, or not through that theater, around that theater? We calculated stuff within, quarters of an inch, which, as an architect and structural engineer, we laugh at that stuff when it's on a piece of paper. If someone puts a quarter-inch dimension on a piece of paper, we laugh at them. I go, "That's ridiculous."
You laugh, I yell.
Nobody's going to take that seriously. But that's what it was. That was what it was down to at that point. We had every little speck of room counted.
We had multiple egress studies, and a lot of outside consultants double, triple checking everything we did, because not only you have to get everybody out of there safely, and God forbid some bad event, but you also have to make it so somebody can't walk out of their hotel room and then just open up the door in their underwear at a Broadway show. There was a lot of conversations about that, quite frankly. So it was definitely lots of work on stairs and egress, but we're good.
And then last couple things about the building. Just talk a little bit, whoever wants to take it, about those doors, those digital doors.
Joe, take it. So the digital doors, which extend from the third floor almost up to the balcony of the fifth floor, open up to a stage, which is going to be, I guess, part of the TSX entertainment.
Yep, a stage that'll open up right onto Times Square, where they can do the NFL draft or the New Year's Eve thing or whatever.
So that stage being obviously probably one of the most integral parts of the entertainment space, has that acoustical separation that we talked about earlier. So that's why, we have that those line partitions, double lined walls, all surrounding the entertainment area.
Right.
And
and those doors they are because they're installed. The framework's installed for them now. They're the world's largest operable LED doors. They open inward, and you could have. And I forget the amount of time, but it's a very short period of time in which they can open up, and you could have a performance that could be performing inward towards an audience, or just turn around and perform outward towards Times Square, and literally in seconds.
Is this the first building ever of its kind that's truly just a living marketing tool?
I believe it is. I mean, the amount, again, a whole different conversation, but the amount of time that we spent on LED systems, whether it be the main LED signage or the actual building, incorporating all those pucks into the entire facade, and the programming and the software that goes into, and the technology that goes into that is astounding. So it literally is. It's a living marketing machine.
Yeah, and meant to also, from what I understand, cross the street and go to some neighboring buildings in terms of content and be able to move around, which is pretty cool. Yeah.
I actually was able to attend one of the fireside chats over at TSX Entertainment, and I found it just remarkable, the concept that they came up with of being able to include live productions and also recording studios, possibly all surrounding a new way of delivering entertainment. It's something that's really never been done before, but I give them a lot of credit for going in that direction.
It's going to be pretty amazing.
So as we begin to wrap up, what next? What's next for the remainder of the project as it finishes up? What's next for Tony, someone like you? Are you going to be moving, an entire skyscraper down the block at some point? What are some of the other things that you're all thinking?
I'm thinking I'm not going to get a call like that again.
Once in a lifetime, right?
But I'll be ready to take the call if it does come through.
I love it. That's great. And what about the building? What's next for the building in terms of finishing, and where?
So we spoke about the theater lift. So after the theater lift was completed, Tony had to complete the cellar slab, because while the theater was being lifted, only the ground floor slab was in place, at which point he fell back, he completed the ground floor slab, and we demoed part of the existing steel truss, which is above the theater. And then during the final lift, we demolished a remainder of the steel truss, which allowed us to build and extend all the north cantilever terraces on the 9th, 10th, and 11th floor, all of which are hung below the box girder, which is quite remarkable.
Which is unbelievable in and of itself.
Yeah,
you actually
a whole nother
see
story.
That done, yeah.
Because
we'll
when you're
do that on another podcast.
if you're in a suite above the theater, you're actually suspended on the largest PT bridge in probably North America.
And it's 4 floors, right, Ben? That hang from that transfer. Yeah.
Yep. It's I think it's one of the largest PT girders in North America.
What does PT mean?
Post-tensioning. Post-tensioning. We have sort of bridge cable strands embedded in concrete, and then we pull them. And as we pull them, it actually lifts the girder up,
right?
And it counteracts the gravity force.
And it's unusual for New York City. Some of our listeners,
it's unusual for New York City, right? Exactly.
Yeah,
just outside,
big deal. Yeah.
Outside of New York City, it's a lot more common. Post-tension slabs, post-tension beams. It was special in New York City, and one of the big reasons is because the site that we're working with.
The density
is just so tight. Trying to bring in steel and build trusses was just it was a study we did with PMG at the beginning of the job, and we did it. Originally, the building was done steel, and then we converted it to post-tension concrete when they just looked at the feasibility of doing it. So,
there's actually, and I have some facts here I'll throw out because they're interesting. There's over 210,000 lineal feet of post-tension cable, 0.6 diameter. 36 tendons, 43 tendons were stressed to over 2 million pounds of force using the largest PT jack in North America. So this jack really was exported from Europe to the United States, and it has to be hung by a crane because it weighs over 7,300 pounds.
Some of those strands had to be brought in from overseas.
That's right.
Our caissons also some of the largest, actually the largest that they make. The steel that we have And then your system, your manifold system, was brought in also from Singapore, special for the job. Yes. So this is not,
very atypical.
Very atypical.
I've been on construction sites since I was 14 years old. I was there the day you were pouring that post-tension girder. I've never seen that many concrete trucks in one place. And literally, I've been on construction sites since I was 14 years old.
And on the hottest day of the summer, had to be the one day we poured that post-tension girder. It was for another time.
So we actually didn't lock off the cables and tension and final tension until the building was topped off. So there was an entire sequencing to that whole post-tensioning. And what was interesting about it was I think no one was quite sure if the building was going to move or not.
What do you mean? I knew exactly what I was going to do the whole time. We told you up front. You didn't. I'm not sure if you believed us or not. And at the end, we hit it dead on.
He did it. He did. He was right on. It was a half inch.
So right now we're restoring the theater. We're fitting the hotel out. Mm-hmm. What else are we doing right now?
So that's it. We're working on critical building infrastructures, doing interior fit-outs, finalizing the hotel room fit-outs, and working our way towards a TCO summer of 2023.
Amazing. Well, is there anything we haven't covered that you guys want to jump in and talk about here before we wrap up?
I'd just like to say that I was asked by many people, Tony, why in your right mind would you do something like this? And I said, well, first of all, because I think I can, but more importantly, I wanted this to be an inspiration to the industry at large, particularly the younger generation, to inspire them to realize that if they look deep into their skill set, anything is possible. And that sometimes you just have to step out of your comfort zone and realize what your full potential could be in order to do things that under normal circumstances you'd never be asked to do. So I really did this more to inspire the younger generation and to give credibility to this great industry of ours.
Awesome. I love it. Well, on that note, Tony, Joe, Benji, Bill, thank you so much for being our guests here on the Building Conversation and Anti-Architect podcast. To see and read more about TSX, probably the best place to start is the website, which is TSX Broadway. There's a lot of articles. There's news releases. There's interviews. There's all of the social media channels, the Instagrams, the Facebooks, Twitters. There's even a TikTok. I'm not exactly sure what's on that, but so there's a lot of information out there. And then come visit it if you're in New York in in the next year and a half or so. It'll be ready for someone to stay there and come watch Bill's band play on the stage one day as well.
Can't wait.
Thank you, guys.
Thank you.
Thank you.